In this problem, we're being asked to compute some probabilities having to do with the incidence of breast cancer and whether or not a test for breast cancer actually picks it up. So the problem says studies show that about 1 woman in 7 will develop breast cancer. Suppose that of those women who develop it, a test is negative 2% of the time, and also generally the test for breast cancer is negative about 85% of the time. And so we want to compute some different probabilities. So I'm going to use a spreadsheet to sort of organize the information that we have here, and I'm gonna give myself 100,000 women. Okay, and then the first thing it says is that 14.3% will develop breast cancer. So I'm organized here into have cancer, doesn't have it, tests negative for cancer, or tests positive. So out of the 100,000 people, the 100,000 women, 14.3% of them actually have cancer. So we can let the computer compute this. So 14,300 of them will have it. That means that the other 85 or so thousand of women won't. Let's see what else we have here. Of those women who develop breast cancer, the test is negative 2% of the time. I think that's called a false negative. So of these 14,300 women, 2% of them will get a negative test. So telling them that they don't have cancer when in fact they do. That means the rest of the women will test positive. So we could do these women minus these women to get that. And then also suppose that in the general population of women, the test for breast cancer is negative about 85% of the time. I read that as just everybody, those who have cancer and those who don't. So among the population of these 100,000 women, the test will be negative 85% of the time. So 0.85 times this is 85,000, and this will be the remaining women. Okay, and we can compute the values that go in these other two cells by recognizing that this cell plus this cell has to add up to this. So to get the number of women that go here, we can just do 85,000 minus 286. And we can do the same thing here, actually. All right, so there's our table, and now we should be able to answer any questions that are asked. Let's see what it says. What's the probability that the woman develops breast cancer? Well, that's given in the problem. 14.3% of us will develop breast cancer. What is the probability that a woman tests negative? And we're told that this happens about 85% of the time, so that goes right there. Given that the woman has breast cancer, what's the probability that she tests negative? And again, that probability is given right here. So D, what is the probability that the woman has cancer and also tests negative? So someone that does both, has cancer and tests negative, there are 286 out of 100,000. So that probability equals 286 divided by 100,000, 0.00286. 0.00286 is what we need for that. And then finally, what's the probability that the woman has breast cancer or tests negative? So has breast cancer are all of these women. Tests negative are all of these women. So we could add those up, but if we do, we will have counted these women twice. So what we need is these women plus these women minus the ones that we've counted twice. So the total number that either have breast cancer or test negative is this quantity, and then the probability that goes along with that is what we get when we take this and divide it by the number of women in the population. So that is the answer to the fourth probability.